Welcome back to the second part of the ScaniT Training video series. In this session, we'll be discussing how to create and capture precise structural data. We will also cover some of the user customization abilities of the program and mention a few of the types of features that can be recorded using ScaniT and your undistorted core tray photographs. So, let's start off where we left off at the previous video, where we had just completed depth registering the core trays using ScaniT. In today's example, you will notice that we will be using a few test core trays where we have some templates displaying predefined planar and linear features to evaluate the accuracy and precision of the program. As we are planning to record structural information today, let's go ahead and turn on the pop-up StereoNet and orthographic projections by clicking the stereo and ortho buttons found at the bottom right of the screen. This will bring up an equal area StereoNet and a three-dimensional orthographic projection for the three core trays being displayed. Each pop-up window can be scaled to a convenient size, and we do this by clicking the small blue square located on the bottom right of each pop-up window and by clicking and dragging it to a size that you're happy with. These are handy tools for geologists to immediately visualize the real space orientation of the structure, enabling instant QA/QC of the data before it has been saved. Next, I think a good place to start would be with the various logging parameters which are required when describing structural and lithological recordings. These are generally commodity, project, or even mine specific. So we need to know that we are able to set up ScaniT for all of our clients' specific different requirements by providing fully customizable setup capabilities. We do this by importing an Excel spreadsheet where we have populated our specific parameters inside of. We have found that many of our clients have documents of this nature on file already, but let's have a closer look at what is required for ScaniT to import your logging parameters. Should you have an existing file with your various logging parameters, we can start by creating our structural dictionary inside of this file using your existing information. We do this by simply creating a new tab and naming it Structural Dictionary, and then by copying and pasting the respective info from the rest of the file onto one page, where the first row, called here Code and Description, will be merged and renamed as the logging parameter in question. We then continue with the rest of the parameters accordingly until we have a completed single tab with all the logging parameters for your operation. It is important to know that the same function can be replicated when it comes to lithological data parameters. Should you not have an existing file with your various logging parameters, we can of course start a new one ourselves. Starting on a new spreadsheet in Excel, as we did in our previous example, we first rename the tab and call it Structural Dictionary. Then, we merge the first two column cells in row 1. We can now start to populate our specific logging parameters relating to structural features in the spreadsheet. Starting with row 1, where we had previously merged the two columns, we insert the logging parameter as a heading of the information. So for this example, let's start with aperture of discontinuity. Once we have the heading in place, in column A we can insert the parameters code, and in column B the full written description. To continue with our previous example, we can start with W for wide aperture and continue with MW for moderately wide aperture, and so on. Remember, should you already have a table with this information, it can be sorted to suit ScaniT's requirements, where the first column contains the code of the parameter and the second column contains the full written description, by simply pasting the information into your structural dictionary table. We can then save this to a convenient file location to be easily imported into ScaniT. We now return to ScaniT. To import our new structural dictionary, we click BH Data from the top tab and then click Import from the drop-down menu. We then locate our dictionary and click Open. ScaniT will then populate your logging parameters accordingly. With the dictionary now successfully imported into ScaniT, we can now start creating planar features. We do this by clicking the Features tab and Add Feature from the drop-down menu. We will then be able to select what type of feature we're looking to log. By clicking the plane box, we can see the various options for the different features ScaniT can record, namely plane, lineation, primary and secondary lithologies, and structural and mineralogical zones. For this example, let's select plane. We can now complete the feature name and description, select a numerical shortcut key for ease of recording this feature when logging. You will now notice a small checkbox indicating if this feature is a natural break. If this is selected, a small natural break will be displayed at the axial depth of the feature. We use this information to calculate RQD on export. Then we can select the feature color by either filling in the RGB color code or by selecting a color from the color wheel on the right hand side. You can create more colors by clicking and dragging from the outermost circle of the color wheel inwards should you find that you are running out of unique colors for your features as you add them. We can also take this opportunity to pre-select the various logging parameters should they be consistent in your ore body. As an example, let's create a test plane feature to record a 30-degree plane. We do this by selecting plane. Let's use test plane 30 and a description of testing a 30-degree planar feature. We then can select a shortcut key of number 3 for the ease of future recall, select a color from the color wheel, and then we're able to set some logging parameters which we've just imported. When you're ready, click the save icon at the top right of the window. We will then be able to log this new feature. You can see in the action bar on the top left of the screen that the current action is shown to be this new feature, test plane 30. We now locate the feature that we would like to log and click anywhere along the trace of the ellipse of the feature. After 3 points, ScaniT will draw a best fit plane and immediately display a flashing plane as a square feature along the borehole in the 3-dimensional orthographic display and a flashing pole in the StereoNet. Until we click enter, this feature has not as yet been recorded. So here the geologist will assess if they believe that this plane of features dip and dip direction has been recorded correctly, and if so, then we can click enter. If not, we can press the Z for undo click or escape key to remove the feature. Once the feature has been saved and recorded, the feature window will display the feature name along with the recorded dip and dip direction rounded to the nearest degree. We can edit the feature should there be anything unique we wish to record. We do this by clicking the small edit pencil located on the top right of the feature window. Here we can add or remove to the written description or even change one of our imported logging parameters. These changes will be unique for this specific feature only and will not change the structural preset information for any previously logged features. This change will be for this feature only. Another way that we can create features would be to create them in Excel and import them back into ScaniT. So similarly to our structural logging dictionary, we can go back into Excel and create and populate our various features, and then import the list back into ScaniT. The easiest way to do this would be to export our dictionaries and databases out of ScaniT. We do this by clicking BH Data and then Export from the drop-down menu. We will now see the ScaniT Export Options window, where we will unselect all items except for dictionaries and databases to be exported. We then click Export, select the save location and click Save. We can then locate and open the exported file. For us to use these spreadsheets for future boreholes, let's just remove the borehole details tab, leaving us just with the structural and lithological dictionaries and database pages. We will now be viewing our structural dictionary which we just created. Clicking across to structural database, we can see the test 30-degree plane that we just made. We can now populate new features inside this table to be re-imported back into ScaniT. So let's create a few more planes. Under Type, we use the letter P for planar features or L for lineations. So for our example, let's create 40, 50, 60 and 70 degree test planes, using unique RGB color codes for each feature. We can either copy and paste the logging parameters from our dictionary here, or we can complete this step inside of ScaniT as well. We then return back to ScaniT, where we can import the structures that we've just created. We do this by clicking BH Data and Import from the drop-down. We locate and select our file and click Open. Now we can see our features we have created by clicking Features and Select Feature from the drop-down. Here we can view, edit, or delete any of our created features. One thing to note is that the keyboard shortcut keys will need to be reassigned. We can do this by clicking the Edit pencil icon located on the right of each feature name. For the ease of logging to come, let's quickly change each feature to have a shortcut key. Once completed, we are ready to log the planar features of our borehole. We can select a structure that we would like to start with. In our example, let's choose the 30 degree test plane again. Locate a feature on a template showing the 30 degree alpha angle, and as we did before, click 3 times along the trace of the ellipse of the feature. Once again, we can see the flashing plots on the StereoNet and the orthographic projections, showing the correct dip and dip direction. Once again, remember the inclination preset of 0.1 negative and an azimuth of 90 degrees. Once we have vetted the pole on the StereoNet and confirmed that it is plotting correctly, we can press Enter to record the feature. While we're on this template, we can now log the 40 degree plane by pressing the number 4 and then clicking 3 times along the trace of the ellipse. Vet our data and press Enter. As you can see, we can now, quicker than ever before, record high precision structural data throughout our borehole. This process will be repeated throughout the entirety of the borehole, and once completed, the data can then be exported to be viewed and assessed in an Excel spreadsheet, and then prepared to be imported into a variety of mine modeling programs or even placed directly into your database management software. This process of creating and recording planar features can all be replicated when wanting to geologically log your lithologies, where the same process of creating a plane can be completed for primary and secondary lithologies. Join us for our next video, where we will go through how to geologically log our borehole using ScaniT.